The Earth's rotation is one of those things we just totally take for granted. It dictates our days, our weather, pretty much our entire existence. But what if it just stopped? Let's really get into this because the answer is one of the most terrifying and frankly awesome thought experiments in all of physics. And leave it to astrophysicist Neil deGrasse Tyson to put it so bluntly. He's not wrong, not at all. The immediate effect wouldn't be some gentle slowdown. Oh no. It would be like the entire planet hitting an invisible cosmic brick wall. And to really get why, you first have to understand the absolutely insane speeds we're talking about. So get this. If you're standing at the equator right now, you and everything around you are moving at over 1,600 kilometers per hour. That is literally faster than the speed of sound. Your house, the oceans, the very air you're breathing, it's all whipping around at this incredible velocity. We don't feel it, of course, because the speed is constant. But if the planet suddenly slammed on the brakes, well, that changes everything. See, the real problem isn't just that the planet stops. It's that everything on the planet wouldn't want to. And this is all because of a fundamental law of physics you deal with every single day. It's the exact same idea. Now just scale that up. Imagine our entire planet is that car, braking from over 1,600 kilometers an hour to zero in an instant. Everything that isn't welded to the planet's bedrock, people, buildings, the topsoil, the oceans, the atmosphere, would just keep going. We'd all be flung eastward in a devastating supersonic wave of pure destruction. Now, here's where the scenario gets really interesting. The outcome, believe it or not, hinges entirely on one single crucial variable. It's not if the Earth stops, but how. And depending on that one factor, you get two completely different but equally world-ending kinds of apocalypse. Oh, you better believe it does. It's everything. Just picture these two possibilities. In one corner, you have the instant, violent, catastrophic halt, and in the other, a slow, gradual grind to a standstill over, say, millions of years. Both of them would completely unmake our world, but in totally different ways. So yeah, you've got two completely different flavors of doom. The sudden stop is all about that instant obliteration from inertia, basically a planet-wide scouring event. The gradual stop, on the other hand, lets us dodge that initial jolt, but instead leads to the slow, complete, and permanent transformation of the planet's entire geography and climate. And this table really drives the point home. Look at how fine that line is. A stop that lasts a millisecond, you'd barely notice it. A tiny tremor, maybe? But stretch that stop out over just 1 second, and you jump straight to catastrophic global destruction. 5 seconds? Extremely catastrophic. This isn't a scenario with a gentle learning curve. The consequences are immediate, and they are absolute. All right, so for the rest of this, let's go down the rabbit hole of that worst-case scenario, the sudden stop. The fallout would happen in a series of devastating waves, hitting every single system that makes our planet livable. And it all starts with the very air around us. Because you gotta remember, it's not just the solid stuff. The atmosphere has inertia too. So while the ground beneath your feet would screech to a halt, that entire blanket of air around the globe would just keep right on going at its original speed. And that would unleash a destructive force unlike anything we can even imagine. We're talking about supersonic winds that would literally scour the surface of the planet clean. This isn't just a storm, it's a global shockwave of air. It would shred forests, pulverize entire cities, and the friction from it would be so intense that it could ignite the ground itself, sparking a worldwide firestorm. And while the atmosphere is busy laying waste to the land, the planet's water would be doing the exact same thing. The oceans, also pulled by inertia, would slosh eastward, creating tsunamis of unimaginable scale. But that's just the immediate problem. The long-term change is even more mind-bending. So right now, the Earth's spin acts like a giant centrifuge. It slings ocean water towards the equator, creating what's called the equatorial bulge. It's pretty subtle, but it means sea levels are way higher at the equator than they are at the poles. Well, if the spin stops, that force just vanishes. And gravity takes over completely. All that water from the equator would just whoosh, rush towards the poles. This would create two massive new polar oceans, submerging huge chunks of North America, Europe, and Asia. And in the middle, the drained equator would rise from the waves as a single massive megacontinent circling the entire globe. The world map would be rewritten in a matter of hours. But beyond all that surface chaos, a deeper, much more sinister problem would be starting. See, our planet's rotation combined with its molten iron core is what generates our magnetic field. It's a process called the dynamo effect. Think of it as an invisible shield protecting us from all the nasty stuff in space. And without that spin, the dynamo shuts down. And without its magnetic field, Earth would be a sitting duck. Deadly radiation from the sun and from deep space would just flood the surface. And even worse, the solar wind, a constant stream of particles from the sun, would start to strip away our atmosphere, molecule by molecule, just like what happened to Mars billions of years ago. Okay, let's switch gears for a second. What if the stop was gradual? And somehow, some pockets of humanity survived all the planetary reshaping. What would life actually be like on a non-spinning Earth? Well, the new reality would be defined by a single, brutal fact. Without that daily rotation, the only thing that defines a day is our orbit around the sun. That means one side of the planet would face the sun for 6 straight months, followed by 6 months of total unending night. And that creates a world of extremes you can't even fathom. Just try to wrap your head around that. The day side would become a scorching desert, hot enough to literally boil water. Any oceans left would just evaporate. Meanwhile, the night side, starved of sunlight for half a year, would become a frozen wasteland, colder than anything we ever experience, even in Antarctica. The only possible place for life to exist would be on the Terminator line, what you might call the twilight zone. It's that narrow band between day and night where temperatures could be mild enough. But here's the catch. This zone would be constantly moving, slowly creeping across the surface. To survive, you'd have to become a permanent nomad, forever chasing the dawn or the dusk. You know, when you really think through this scenario, it reveals a pretty profound truth. Our entire world is delicately balanced on this silent, steady motion. It's a force we never, ever feel, but it's responsible for the stability of pretty much everything we depend on. Thankfully, and this is very good news, this is purely a thought experiment. There's no known force in our solar system powerful enough to just stop the Earth in its tracks. In fact, our planet's rotation is slowing down, but it's happening at a rate that is so incredibly, incredibly slow, it's almost impossible to notice. Thanks to the gravitational pull of our moon, the length of an Earth day gets longer by about 1.8 milliseconds every century. So at that rate, it would take billions of years for our planet to grind to a natural halt. And by then, our sun will have already expanded and swallowed the Earth anyway. So yeah, we're safe. Ultimately, what this whole thought experiment really shows us is that we live on a planet governed by these immense, invisible forces. The Earth's spin is just one of them, a constant, silent dance that makes our climate, our geography, and our very lives possible. It kind of makes you wonder, doesn't it? What other cosmic threads are holding our world together completely unnoticed?